Hello everyone and welcome to yet another problem from Geeks for Geeks. The problem is pretty straightforward. We are asked to construct a list using the given Q XOR queries. So which says initially the list S has contains only a single value 0. There will be Q queries of the following types. So type 0, type 1. Of type 0 query, we are given a number x which is said to insert that number x within the list. And for type 1 query, we need to replace the element in S. So for type 1 query with an element x, for every element in S, we need to replace it with A XOR X. So this would be more clear with an example 1. So let's see this. So we have 5 queries such in this way, and we have 0th query. So initially the value was 0, 0th query of 6, which means add a 6 to the list, add 3 to the list, same. Then 0 2, add 2 to the list, 1 4, XOR with 4 for each and every element within the list. So XORing 0 with 4 gives you 4, XORing 6 with 4 gives you 2, 3 with 4 gives 7, 2 with 4 gives 6. Same with 5, 4 with 5 gives 1, 2, 5, 7, and so on. And ultimately it says us to return the sorted list after performing given Q queries. So post sorting, the return resultant list is of a form 1, 2, 3, 7. Pretty much straightforward. So one thing which we can do over here is we can just take a query type, and based on this, if it is addition, we can go ahead and add. But if it is an iteration, or if it is transformation, we can just go ahead and transform each and every element within an array. So what would be the time complexity in such approach? Basically it's a very naive approach, we are not going to implement it but still I wanted to know the time complexity. So Q queries into n, which is the average size of the list which it will get added upon, which is not very good. Let's suppose q is equal to n. In that case it is n square. Q is greater than n, so in that case it's greater than n square. So obviously that is not very good solution to be go with. So how can we deal with this one? So first of all, we can have an approach where we won't go ahead and just directly transform it. So the bottleneck comes over here from the transformation side. So transformation, so there are only two operations, one is addition and one is transformation. Addition, we can get it pretty sure that we can do it within O of one time complexity with the help of any array list, linked list, anything. So here it's array list given. So anyways, with an array list we can do it with the average time complexity of O of 1, so there is not such problem over here. But with the transformation, can we do better? So the answer comes out yes, we can, in the following manner. So let's suppose we are at a position this, so we have an array. Let's suppose we start from the 0 position. Let's take it in such a way. We start with 0. Well, initial value was 0. Again we wanted to add the query of 0 6, so add 6, or 36, or I'll just say 0 6, which means add 6. So 0 6, so it says add 3. By the way, I'm taking just the example string only, so nothing to worry about it. So 0, then 6 was the original thing, and post that we added 3, so 3 is the 1. Next we have 0 2, 0 2, adding that would give us 3 2. Next we have 1 4. So 1 4 is quite interesting now. So till now we have only addition queries, but we wanted to also have a XOR query. Now here comes an XOR operation. So we wanted to have 4 XOR. So one thing is we can just directly go ahead and do XOR of each and every element, such as this 6 3 2. I'll just copy paste it with the XOR. Even typing makes it more time consuming. Yeah, basically we have iterated each and everything. So we can do one thing that, but this is very much time consuming. Can we do it better? So the answer comes yes. We will just for now hold the XOR of 4. Be with me for a while, we'll get to know what's happening next. So we are just over here, and we again came up with another XOR of element 5. So shall we go ahead and do XOR of 5 as well, which will make us XOR of 5. Do you see any similarities over here? XOR of 4, XOR of 5 we are doing. Yes, these are repetitive elements, right? 4 5 4 5 4 5, you can see in everything. So can't we take this common and just take 4 XOR with 5, and ultimately we can take this operation, we can compute this operation in such a way that 4 XOR 5 is nothing but 1, and hence we need to go ahead and do XOR of with only 1. So 1, then we have 7 2 and 3. Obviously after sorting we'll get this array. So isn't that great? So let's confirm it with the second solution as well. But wait a second, here with example 2, we have a problem. Initially we had an array 0 2. Now we are saying to get an XOR of 3, but post this we also adding 5. Would it alter this array? Yes, it would. It would only for a while, till the point we don't consider a new element 5, new add 5, or I'll say post XORing 3 we added 5, then we can do XORing of 3. So that's not a very valid way to go ahead with. Can we reverse the XOR operation for this? Yeah, we absolutely can, because A XOR X is X. So we can just go ahead and negate the XORing with 0 2 and 5 XOR 3, wait for a while, and XORing ultimately with 3. So this will, in the result, so by the way this is the result, right? So within the result it will go ahead and XOR ultimately 3 with each and every element with 3. So I'll take 3 2 and 3, it's 1, and 5 3 and 3. So 3 3 would negate themselves, and ultimately it would be 5, taking it 3 1 5 3 1 5, which we wanted, and the ultimate sorted value is 1 3 5. Isn't that interesting? So it looks great to me. So what are we waiting for? Let's go ahead and implement this. So I'll take XOR of initially value 0, which will denote the XORing elements which we would need to operate ultimately in the last operation. So I'll say XOR param to be considered in the final result. Ultimately now we need to go ahead and check one by one queries. So let's take this query. So I'll say int query within queries. I'll take final int, or instead of taking final int I'll take if query of 0 is equal to 1, then it's an add query, else it's a transform query. So with an add query we are going to add it, and with a transform query we need to update only the XOR operation. So let's go ahead with the transform query first. We'll go ahead XORing of the new query, new element, which is first one. So zeroth position is a query type, second is the x, and now we are going to add it. So remember, we need to add post XORing with the x element 3. So element 3 was the that time XOR or the current XOR. So I'll go ahead and with the list dot add, I'll say query of 1, or I'll just XORing with XOR. Cool. But what is list? List is an array list. So array list of integer is a list which is itself an array list. So by the way, this is very wrong practice we need to follow. Whensoever you wanted to return any type, it's a very good indication, or it's a very good practice when you return with a list. Well, it's directly from G of G, so we are not going to much bother about it, and we are just doing our jobs. That's it. So we added a list and we transformed a query. So semicolon was missing. Okay. So ultimately we need to do a result operation, result computation. So what I will do first is I'll sort up the list. So collections dot sort list, or you can do it post operation as well. First of all, I'll just go ahead and update each and every. Remember, we need to also update these elements to get to this, these elements to get to this. So that's all we are going to do over here. 0 is less than list dot size I plus plus, and within this I'll go ahead list dot set I with list dot get I XOR the XOR element. Cool. That's all what we want, and ultimately returning the list. So let's try to submit this. Oops, I think we have not included 0th position. Also, if the query type is 0, then we wanted to add, not 1 we wanted to add. So let's go ahead with this. Yep, it seems correct now. Well, I think this will work. So the time complexity for this approach is O of n, which is linear, and auxiliary space. So there is no auxiliary space except this XOR. The result space, so okay, it has passed all the test cases. So the result space is all that which it requires, and which is a demand for the question itself. So apart from this result space, we are not consuming any other spaces. So again, the time complexity is O of n for this, but O of n log n for this. So only the sort operation takes a lot of time. So that's the bottleneck over here. Although you can use radix sort and multiple sorts if your sizes are limited, but that's up to you. And yeah, so Q log Q. That's all what we want. Auxiliary space L output specific requirements, and that's all it is. So I guess you got this point, and for more such thing, I'll see you in the next one.